Hello, everyone. Mr. Minix, my name. Math is my game. I'm a 15-year veteran at Algebra 2. And today what we're looking at is factoring part one. Um, I'm actually using some homework assignment that my student teacher a few years back did. I like the way he put it together. In this first part, we're going to talk about greatest common factors today, or GCFs for short. We're going to talk about what factors are. And then that last part where it says a equals 1, the type of factoring that we most often do is where we take a trinomial. We take a trinomial, something like x squared minus 8x plus something. I don't know, maybe um, plus, what would it have to be? I guess it would be plus 7, something like that. And we break that down into two binomials. Okay. So some terminology you'll hear me use. What we see here is a trinomial. In fact, it's not just any old trinomial. It's a quadratic. It's a quadratic trinomial. This term here is, or this expression I should say is. What makes that expression a trinomial? What makes that expression a trinomial is the fact that it has not one, not two, but three terms. And in chapter 5, we're going to study polynomials. What makes that trinomial quadratic? What makes that trinomial quadratic? Let me see if my highlighter is going to work. What makes it quadratic is that biggest exponent of 2. Okay, so factoring, we're going to be taking those quadratic trinomials, and we're going to be trying to make them, trying to put them into the form where we're going to have the product of two binomials. So we're going to try to break this down into the product of. So when I say the product of, I just mean that this operation between these two things, we're multiplying the one thing by the other thing. The fact that we have two of them, well, there's one there, and we're going to have two binomials. So binomial is going to have two terms, so an x and an x. And somebody might already know how to factor this one, actually. Already know what the answer is. Yeah. 7 and 1 would be the numbers that we would put in here, and then you just got to figure out the SIG. 7 and 1. So then we just need to figure out the SIG and S, the signs to go in there. And let me see if I could get my magic marker working. Maybe the star. Maybe the star will be better. Maybe the star. Yeah. So if we look at that positive sign right there, that positive sign is a real nice bit of information. You know what it says about those numbers 1 and 7? It says they have to have the same sign, right? Because a positive times a positive is positive, and a negative times a negative is a positive. So we could think, okay, well, maybe they both have to be have to be plus. Well, the cool thing about math is you can actually check to see if you're right. That would give you plus 7x. That would give you plus 1x. And if we think about plus 7x and plus 1x, that's actually equal to plus 8x. But we need to get minus 8x. So I guess that means our signs are wrong. So what should our signs be here? Negative and... Well, we said because of the star, they have to be the same sign. So how about negative and negative, right? So that's the kind of thing that we're going to be doing today, okay? If that example just went right over your head, sorry. We'll come back and do more of those. But before we dive into those, and there's going to be like 5 or 6 examples at the end, I'd like to be a big fine woman and back that thing up. Do you guys know that song? She's a big fine woman, won't you back that thing up? Nobody listens to rap? Very censored? Okay. All right. So let's look at GCFs. GCFs. We know that that's an acronym. It stands for greatest common factors. Greatest common factors. The reason we talk about GCFs is sometimes when we factor, we need to factor out or undistribute a greatest common factor. So if we just look at example 1, find the GCF of 80 and 18. Suppose we had to find the greatest common factor of 80 and 18. Now this is different than finding a least common multiple. When we studied fractions, we talked about least common multiples. Well, now we're talking about greatest common factors. Interesting thing about least common multiples have to be as big as the biggest number. Greatest common factors can be much smaller. So we need to consider factors. We need to find factors of each number. Let's see if we can find the factors of 80. The factors of 80. 1 times 80 is 80. 2 times 40 is 80. 80 is not divisible by 3. I guess 80 is divisible by 4. How many times? Okay, 4 times 20 would be 80. And I think that's it. There's no other factors of 80, right? Oh, 8 and 10. And that's going to do it. Okay, so those are 80's factors. Now, if we look at the factors of 18, if we look at the factors of 18, we'll have 1 and 18, 2 and 9, and 3 and 6. And I think that's it, right? So if we look at those two lists, what's the greatest factor that 80 and 18 have in common? 2, and it's not very big, but that is the greatest common factor of those two numbers. How's everybody doing? All right? Cool beans. So if you ever have to use the calculator to find factors of a number, I want to show you what it can and can't do. I'm actually using the TI Nspire Cast today, but the TI Nspire that you all use will do the same thing. If you want a greatest common factor, you type in GCD of 80 and 18. And there it is, 2. That's the best we can do. Okay. So to be clear, if you're using a TI Nspire greatest common factor, on the TI Nspire you use GCD. So the deal is divisors and factors are almost the same thing. Really not much of a difference between divisors and factors. It's kind of like semantics if you're talking about automobiles. Is it a car? Is it a vehicle? Yes. Yes. Cars and vehicles, same thing. All right. Are there any questions up to this point? So I want to look at example 2. Example 2, factor out the GCF. Factor out the GCF. And we'll look at a whole bunch of these. I got 1, 2, 3, 4. So we'll look at example 2, part A, part B, part C, and part D. Part A is going to be 6x squared minus 18x. Part B will have 25x squared plus 10x. Part C, we're going to look at 3x squared plus 6x. And part D, my second personal favorite, 5x squared plus 5x. So when I hear the word factor, one thing that I heard somebody say one time that just blew my mind. They said undistribute. You know the distributive property, right? If you think a little sidebar, the distributive property says A times B plus C is equal to AB plus AC. Usually when we think of the distributive property, we think of multiplying, and we think of the distributive property heading in this direction, right? But did you know the distributive property works in the other direction? So what I'm saying is you could think of AB plus AC as A times the group of B plus C. Not a whole lot of people think of the distributive property working that way. But the distributive property is essentially what factoring is. Just in the other direction. So when we go to factor out a GCF, I'm going to bring the blinds in. I just want to look at number A here for a minute. What I've got to do is I've got to look at these two terms, and I got to find the factors of each term. and I got to find the greatest factor that those two terms have in common. I heard somebody say 3. We can actually do better than 3. And this is why it pays to list out all the things. One thing that I like to do is I like to look at the prime factorization. If I take 6x squared, I'm going to go ahead and take 6 and break it into its prime factors. That's going to be 2 times 3. And again, on the calculator, if you ever want to find prime factors, you can actually type factor. You could type factor. You could put 6, and it'll give you the prime factors of 6. Okay, so the TI Nspire will find prime factors for you. So 6 is 2 times 3, and x squared, of course, we know is x times x, right? Everybody good with that so far? Cool. Now, the minus sign, I'm going to kind of just forget about it for now. It's there, but I'm just going to disregard it for now. So 18, I know, is 2 times 9, so that's going to be 2 times 3 times 3 times x. So everybody see what I did there, how I just kind of expanded those out into their most basic factors? So let's see what they have in common. Somebody mentioned 3. Well, we could do a lot better than 3. We could do a lot better than 3 because there's a 2 in this one, and there's a 2 in this one, and there's a 3 in this one, and there's a 3 in this one, and there's an x in this one, and there's an x in this one. So our greatest common factor is what? 6x. So the GCF in this particular problem is 6x. So the GCF is 6x. But the directions ask us not to find the GCF. It says factor it out. So what that means to factor it out is the GCF is going to sit in front of some group like that. And then what goes in the parentheses is whatever's left once we factor out that 6x. Well, let's see what's left. Out of this first term over here, what's left? Just an x, right? So over here is just an x. And then if I look at this other term, what's left? A 3. And now is where I got to think about that sign. That sign separating the terms was what? A negative or a minus. And that's my answer. That's my answer right there. That whole thing right there. 6x times the group of x minus 3. That's my answer. So when we factor out a GCF, the GCF is going to sit in front of some quantity. And that's it. That's what we do. What do you think of that? Does it make sense? For the most part? So here's where you wish you had Darth Vader. You know about Darth Vader, right? What he told Luke Skywalker. Did I tell you this one? Maybe I haven't.
Luke, I know what you're getting for Christmas. I felt your presence.
Sorry, that was bad. So here's why you might want this calculator. Factor the expression 6x squared minus 18x. And I want to factor this for the variable x. And watch this. You ready? This is a TI-inspired cast. This is Darth Vader. Your yellow ones will not do this. Boom. Look at that. Your regular TI-Inspire won't do that. TI-Inspire cast. Darth Vader. I don't even know where mine is. Here's mine. Darth Vader. This one will do that. So, all right. But you could do that. I think we can handle something like number B here. I hope. So we're trying to factor out the GCF of 25x squared plus 10x. Now at this point, I bet somebody knows what the GCF is. Not just 5x, right? So we're going to factor out, did somebody ask why the x? Okay. Well, all right. Well, 5x is the GCF, so this is going to be 5x times the group of. Now, if you don't break it down like we did in the last example, Let's think. Let's divide 25x squared by 5x. 25 divided by 5 is 5, and x squared divided by x is x. And then we have a plus sign. And then 10 divided by 5 is 2, and x divided by x is, they cancel, so, what, right? The x's cancel, so it's just 5x plus 2 there. There it is. How do we feel about this factoring out of GCF? Does it make sense? A little bit? Let's try another one. Let's try another one. Number C here, what's our GCF going to be? 3x, right? So we factor out a 3x. So 3 divided by 3 is going to be 1, so there's no number in the first term, but x squared divided by x is x. And then 6 divided by 3 we know is 2, but x divided by x, the x's cancel, right? So that's going to be 3x times the group of x plus 2. Okay? And lastly, but definitely not leastly, what's the GCF here? Not 5, 5x. Okay? Because this is 5 times x plus 5 times x, right? All right. So this is where we got to be careful. We know our GCF is 5x, right? 5x. So what's left? X plus, who said 1? Oh my gosh. How did you know that it was 1? Because something divided by itself is 1, right? Cool beans. Are there any questions about this factoring out a GCF idea? Going once, going twice. I want to put up an example that's probably the nastiest example ever of GCFs. Example 3. Find the GCF of 16 a squared b cubed c to the 4th xy 32 a b squared c cubed x squared y and 48 ab c squared x cubed y squared. Let's see if we can find the GCF here. So when you look at this, remember LCMs have to be at least as big as the biggest one, but GCFs can be much smaller. So we got to look at each term individually. So we got 16, which breaks down into 2 times 2 times 2 times 2. I'm just going to look at the numbers for now. If I go to 32, 32 is going to be 2 times 2 times 2 times 2 times 2. And if I look at 48, 48 is 2 times 2 times 2 times 2 times 3. So from a numeric perspective, as far as just the numbers go, what's the GCF? 16, right? 2 times 2 times 2 times 2. Okay. So our answer then numerically is going to be 16. So that takes care of all those. That takes care of all those. That takes care of... No, it doesn't take care of all these. My bad. It takes care of 4 of those, right? And it takes care of these 2s. All right. So now we got to look at the other stuff. So we have an A and an A and a B and a B and a B and a C and a C and a C and a C and an X and a Y. Oh, man. And then we have an A and a B and a B and a C and a C and a C and an X and an Y. And then we got to look at that last one. That last one's got an A, a B, a C, an X, an X, an X, and a Y and a Y. Oh, man. So what's the most stuff that they have in common with respect to the A's? A to the first power, right? Just one of those A's. So our GCF then is going to be 16A. So that would take care of that one of those. That would take care of that one and that one. Now with respect to the B's, what's the best we can do? B to the first power, right? Okay, so that would take care of one of those, and that would take care of one of those, and this only has the one. And then with respect to the C, what do we got? C to the second, C squared, good. C squared. So that would take care of both of those, That'd take care of 2 of these, and that'd take care of 2 of these. With respect to x, what can we do? Just x to the first, right? So x, so that's going to take care of that one, and that one, and that one. And then with respect to the y's, y to the first. So if you ever have to do one that nasty, really all you do is just kind of expand these out, and they're really not that bad. There's this one video I watched that says, need a hand? Expand. So if you expand these out, it's almost foolproof. Can we watch the video? If we did watch the video in a pre-algebra class, awesome. If I can find that little segment, I'm gonna post it to the website. All right. So I think we got these GCFs down. Factors of a number, I think we're good with that. So I think really all we need to do now is just look at a few examples of factoring. So let's try this one. Example 4, factor x squared minus 11x plus 30. So one thing that the name factor implies, one thing you really can't do without is finding factors of a number. I've tutored so many people in this. My brother-in-law's girlfriend's daughter was really struggling in her senior year. She had to pass Algebra 2 to graduate, and she couldn't factor if her life depended on it. And it's not that she couldn't put the stuff together, she just didn't know how to find factors of a number. If you showed her the factors, she could do it. And I think that that's where a lot of high school students are. What we got to do is we got to be able to break 30 down, and if you can't do this, you're not going to be able to factor unless you look at somebody else's paper and get the answer off of them. And that's not cool. I don't like that. That's not going to get you anywhere in life. So we have to be able to find factors of 30, 1 and 30, 2 and 15, 3 and 10. I guess this does not factor. Guess we can't do this one, can we? We can. And I don't think the answer is going to be on our cell phone. 5 and 6? What do you mean 5 and 6? What am I going to do with 5 and 6? Oh, so we want some pair of these. 1 plus or minus 30 would be either 29 or 31, positive or negative. So you're saying we want these things that add up to be this middle term. That's what you're saying. So if we think about 1 plus or minus 30, that's going to be 29 or 31. That's not going to work. 2 plus or minus 15, that's going to be what, 17 or 13? That's not going to work. 3 plus or minus 10, that's going to be 7 or 13. That's not going to work. And 5 and 6, you're saying 5 and 6 can make 11? Oh. So we're going to have 2 binomials, x and an x. And remember with our signs, this positive tells us that those signs here and here will be el mismo, will be the same, right? Now the interesting thing is this term right here tells us what those signs have to be. They have to be negative, both of them. So it's going to be a minus and a 5 and a 6, and that's it, huh? What do you think? Everybody cool so far? All right. Whelp. I really want whelp to be a word. Example 5, A and B. Here we go. X squared plus x minus 6. I got news for you. There's a quiz on Friday. These ones will be on it. X squared plus 5x minus 6. And your quiz Friday's open note. Now these ones look very similar. They look very similar, don't they? And where people screw these ones up is not that they don't know factors, it's they don't realize what has to happen with the SIGNS, the signs. If we think about 6, it's 1 and 6, 2 and 3. So we could set up this and this and this and this and this. Now what we got to realize on this one is that 6 on the end, you know that 6 is negative. You know what that means about the signs? One has to be positive, one has to be negative, right? Okay. And honestly, if you take this factor and write it over here, or this factor over here, the order doesn't matter because of the commutative property of multiplication. Okay. So one of them is going to be positive, one of them is going to be negative, and it's going to be the same thing for this problem too. So the deal is, in the one on the left, we want those opposites. We want those opposites to add up to a middle term of 1, right? So what are we going to have to use there? I heard a 1 and 6. 1 plus 6 would be 7. 1 minus 6 would be 5. That's not going to make 1 on the left. Going to have to go with 2 and 3, right? We're looking at the one on the left over here. So we're going to have to go with the 2 and a 3. So can I just haphazardly put these 2s and 3s in wherever I want? In other words, can I just put the 2 in here and hope that's right and put the 3 in here and hope that's right? No, you could FOIL. This inner product is plus 2x. This outer product is minus 3x, and those add up to be minus x, but we got to make it add up to be plus x. Oh, man. So what's that mean then? We got to switch them around, yeah. So we want the positive one to be the 3 and the negative one to be the 2, right? Everybody cool with that one? Questions about it? Okay, let's look at this one over here. This one over here, we want our terms to add up to 5. Well, 2 and 3 add up to 5, don't they? 2 plus 3 is 5. But there's a big but. The signs, one of them has to be positive and one has to be negative, right? Everybody see that? There's like 4 of these just like this on the quiz on Friday. All right, so what are we going to have to go with here then? Got to go with the 6 and the 1. And again, can I haphazardly put them anywhere I want to? No. So I'm thinking about this before I place anything. I'm coming up with plus 5, right? So if I go plus 6 minus 1, that'll get it done, right? So plus 6 minus 1. What do you think about that? Does the idea of the signs make sense? Foiling to check. Do you see why we did the foiling championship? Because if you're good at foiling, you should be able to check your factoring pretty quick. Okay. All right. So I got a couple more examples and that's it. Here we go. Just 2 more. Last 2. X squared plus 10x minus 144. And x squared plus 14x minus 51. Now, just so you know, if something doesn't factor, the abbreviation we use is DNF. If something doesn't factor, the abbreviation we use is DNF. I see a lot of people write NS. We're not solving anything. We solve equations. These aren't equations, okay? We factor expressions. If it doesn't factor, we would say DNF. But I've got news for you. All these ones that I picked today do factor. Which one we want to start with? The one on the left or the one on the right? The one on the left? All right. So we got to be good with finding factors, and 144's got a boatload of them. And remember, we're looking for ones that add up to be 10, right? Oh, gosh. Well, 1 and 144 surely don't. And 2 and 72 definitely don't. And 3 and 48 definitely don't. And 4 and 36 don't. 5 doesn't work. 6 does 24 times, but those don't add up to 10. Holy moly. 7 doesn't go into 144. 8 does 18 times. 144 is divisible by 9 16 times. 144 is also divisible by 12 times. 8 and 18? All right. So we're going to set this up. X and an 8. X and an 18. We want those to add up to be positive 10, but they have to have opposite signs because the negative 144. So what are we going to do? Minus on the 8 and plus on the 18. There it is. What do you think? Like a boss, huh? Cool. Like a boss. Well, the last one, we got to try to break 15 down if we can. 15's divisible by 1 because everything is. 15's not divisible by 2 because it's not even. Or 50, I said 15. Dyslexia strikes again. Dang it. 51. 51. Is 51 divisible by 3? 17 times. Because 5 plus 1 is 6, and 6 is divisible by 3. So 3 and 17. So when we set this up, we're going to have an x and a 3, an x and a 17, plus on the 17, minus on the 3. This last product would be minus 51. It's cool. It's cool. We're good. What do you think? Factoring part 1, we got a wrap on it.
Good.
I hope everybody has the best day of their lives. Shout out to the future Mr. Minnick.